Hey guys, so far we have learned that an atom is made of electron which make the negative part of the atom, and when we remove these electrons, what we get is the positive part of the atom. But we still don't know how are these positive part and negative part arranged inside an atom. Well, just like you, scientists were curious to know what is the structure of atom. They wanted to know what makes an atom so stable that it was believed to be indivisible for thousands of years. To answer these questions, several scientists proposed a model of an atom. But there were only few models which were widely accepted. One was proposed by J.J. Thomson and the other was proposed by Rutherford. Based on the studies done on cathode rays and anode rays, J.J. Thomson was the first person to propose the internal structure of an atom. In his model, he proposed that the positive charge is uniformly distributed over the spherical atom and the electrons are embedded into it. An important feature of this model was that mass was uniformly distributed all over the atom. He compared his model with the famous English dessert, the plum pudding, where he said the small pieces of plums are like electrons and the positive charge is like the pudding which is distributed all over it. Now, some people also compare his model with that of a watermelon, where the red region is the positive charge and the seeds are like electrons. Even though Thomson's model was able to explain the neutrality of an atom, it was later discarded when it was found in disagreement with the result of an experiment that was done by Rutherford. So the question is, what did Rutherford do? Let's find out. So Rutherford was known for his work in radioactivity. Well, radioactivity is a property of radioactive material, which are unstable atoms which decay very easily, and when they decay, they emit high energy radiation and some charged particles like alpha particles. Now, alpha particles are these positively charged particles which are so tiny that they can even pass through atom. So Rutherford wanted to check experimentally how alpha particles would interact with atoms. That's why he and his student bombarded a very thin metal sheet of gold with alpha particles, and this experiment was known as gold foil experiment. Now you might wonder, why did they use gold? Well, gold is the only metal which can be made into very thin sheets. And do you know, these sheets were so thin that they were only 1,000 atoms thick. So, are you curious to know what would happen? Let's find out. They used a radioactive material as a source of alpha particles. A stream of these particles from a radioactive source were directed at very thin gold foil. They placed a circular zinc sulfide screen around it, and whenever alpha particles struck the screen, a tiny flash of light was produced at that point. So they had this belief that atom was not very densely packed, and that's why they were expecting that alpha particle would simply pass through the atom. But what they found was something unexpected. What they found was 99% of the alpha particles simply passed through the atoms, but fraction of them were deflected. And most shockingly, they found that 1 in 20,000 alpha particles was totally bounced back. If I have to put that in Rutherford's words, he said that this is as incredible as if you fire a 15-inch shell towards a tissue paper, it comes back and hits you. Since most of the alpha particles simply pass through the atom, we can say that most of the space in the atom is empty. And for the few particles which were deflected by large angles, we can say that this was due to positive charge which is densely packed in the center of the atom. Based on these observations, Rutherford concluded that the positive charge and most of the mass of the atom is concentrated in an extremely small region which he called as nucleus. He also proposed that the positive particles live within the nucleus and he called them protons. To support his theory further, he calculated the volume of the nucleus and showed that the volume of the nucleus is negligible in front of the volume of the atom. Put that in perspective. Imagine if atom is as big as football stadium. Then, to look for the nucleus, we'll have to zoom into the center and we'll finally find the nucleus. And it will be as small as a marble. And that's how empty is an atom. He also suggested that the nucleus is surrounded by electrons. And electrons revolve around the nucleus at very high speed in circular path which is called orbit. This model is very much similar to our solar system, where Just like sun, nucleus is in center and electrons are revolving like planets. Amazing, right? Comparing the vast solar system with an atom which is so tiny. But there was a problem. So it was known to scientists that if a charged particle moves in a circular path, it gives out radiation. So similarly, if electron is revolving around the nucleus, it would also give out radiation. If the electron is giving out radiation, then it will lose its energy and therefore it will come closer to the nucleus. So if the electron keeps on revolving on the nucleus, then it will keep on giving out radiation. Therefore, it will keep coming closer and closer to the nucleus and eventually fall into the nucleus and atom will collapse. But on the contrary, we already know that atom is in fact extremely stable. While Rutherford's conclusion that most of the atom was empty space and the positive charge was densely packed inside the nucleus was correct and still holds true, his conclusion could not take account for all the mass inside the nucleus. Therefore, many people believe that there must be another particle which is responsible for this unaccounted mass. So many people kept on looking for this particle, and after 20 years, in 1932, James Chadwick found neutron, an uncharged dense particle which has mass same as proton and also resides in the nucleus. So, looks like finally we have all the subatomic particles, the electron, neutron and proton. So we can say that an atom is made of electron, proton and a neutron. So what's next? Well, in the upcoming videos, we will see how Niels Bohr improved upon Rutherford's model. Until then, stay tuned. For now, let's summarize all the things that we have learned today. We saw J.J. Thomson propose that the positive charge is uniformly distributed inside an atom and electrons are embedded into it. He assumed that the mass of the atom is also uniformly distributed all over the atom. Alpha particles are tiny charged particles which can even pass through atoms. Rutherford and his students bombarded a very thin gold foil with alpha particles and found most of the alpha particles passed through the gold foil, but some were deflected by small angles and 1 in 20,000 alpha particles bounced back. Based on these observations, Rutherford concluded that most of the atom is empty space and the positive charge and the mass of the atom is concentrated inside the nucleus. He also said the positive particles, called protons, lay inside the nucleus. James Chadwick discovered an uncharged dense particle which had same mass as proton, which he called neutron.